Now that we've learned how to organize and display our data to find patterns, we're going to start looking at some calculations we can do to further describe the data. We call this part descriptive statistics. And our first idea for today is how to describe our data in terms of the central tendencies. Central tendencies is how the data clusters in the middle. Right? We know it as the word average. Now, that's not the only thing we can do, but for today we'll start with average. Tomorrow we'll look at spread and how that means how the data is distributed, how it's dispersed, okay, and how consistent the data is. The three main methods we have for measuring average or central tendencies, we remember from way back when, are mean, median, and mode. The mean is the arithmetic average. Okay, it's arithmetic. We actually have to do some math here. And the way we're going to do it, it's done the same way, just two different symbols here. For population and sample, and we use the fancy U, we call this mu for a population. And what you need to do is take the sum of all the values, so add up every piece of data and divide by how many there are. And the same is true for when you do a sample mean. We just use a different symbol we call X bar. Okay. The median, another way of measuring average, is the middle value when the data is arranged from smallest to largest. So for this one, we don't have to do arithmetic, but we have to put them in order. There is a special circumstance. If there are an even number of data, you have to find the average of the two middle terms. So for instance, if I have the numbers 1, 2, 3, and 4, those are in order, there is no middle number, but halfway between 2 and 3, or in other words, 2 plus 3 divided by 2, is 2.5. That's our median. And then the last one, the mode, is our most frequently occurring value. And notice here I put in brackets S values. There could be more than one of them. For instance, if I go back to this example over here, my mean is 1, or sorry, my mode is 1 and 4. There also could be no mode. If I had just the digits 1, 2, 3, 4, there is no mode because there's nothing common. They'll each only show up once. So it has to show up more than once to be a mode. Okay, so we're going to try one. Try a nice warm-up here. Find the mean, median, mode for this lovely set of digits. So because I don't know if it's a sample or mean, a sample or population, I could use mean as either one of the symbols. But either way, I need to add up 4 plus 2 plus 3 plus 8, 1, 6, 4, 9, 4, 3, and 2. Add them all up and divide by how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, get our calculators out. If we add all those up, it should come out to 46 over 11, 4.18. There's our arithmetic average. Okay, we try our median. For our median, we got to put them in the right order. I usually use the letter MED for median. So I've got a 1, and then I've got 2 2s, and then I've got 1, 2, 3, 2 3s, and I got 3 4s, and no 5s. I got a 6, I got an 8, and a 9. So just count how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so I have 11 pieces of data. Find the middle number. A little trick for you. If you know how many pieces of data I have, always add 1, then divide by 2, and I'll tell you where the middle is. Where middle is. So in our case, there's 11 pieces of data. 12 divided by 2 is 6. The 6th piece of data. So 1, 2, 3, 4, 5, 6. My median is 4. I should actually move this down here. That was just our process. And then the last one, our mode, is our most common number. It's helpful to put them in order so you can see what's most common. There's 3 4s. So our mode is 4. Okay, mean, median, mode by hand. The nice thing about these calculations is once we know how they work, we can actually use them to solve problems. So for example, a sample of 20 objects has a mean of 17. A sample of 24 different objects has a mean of 14. What's the mean of all 45 objects? Well, the good thing about mean is it's a calculation, which has a formula. The mean is found by the sum of everything divided by how many there are. So if I know the mean is 17, and I know there are 20 objects, I can figure out what they actually add up to. I can do this by cross-multiplying. You put a 1 underneath. 1 times that is just that. 17 times 20 is 340. So the first group of objects, regardless of what their numbers are, add up to 340. Well, the same is true for the next group of objects. Their mean is 14, but this time there are 25 of them. So if I do my cross-multiplying little trick again, 14 times 25 comes out to 350. And I know the sum of the second group. Now the question wasn't what is the sum of the objects, we wanted to know what the overall mean is. So our overall mean is the sum of the first group plus the sum of the second group divided by the number of things in each group. So you can think of these as group 1 and group 2. Or in other words, 340 plus 350 divided by 20 plus 25, which if we do the math right, comes out to 15.33. Yeah, we figure out the overall average without actually knowing the raw data, but using some problem solving. And let's see if you guys can try the next one. Another problem solving question about mean, median, mode. So the mode of the following data is 5, the median is 6, and the mean is 6.5. Determine the unknown values. So the fact that the mode is 5 tells us the most common number is a 5. Well, right now I see there's 2 5s, but I also notice 2 1s. So for 5 to be the mode, it has to be the most common. M has to be 5. There's no choice. I need to have more of them than anything else. The median is 6. Well, I don't know if that really helps me at all, because it tells me the median is right here, but I don't know that it's necessarily helpful. But let's go back to that mean idea again. My mean is 6.5. We did a second ago a calculation, right? We said we can add them all up, which I can do here. And we just figured out was 5, and 5, and 5, and 7, and 8, and 9, and 10, and N. I'm just going to move all this over here because I'm running out of room. Let's do this. Down here. And 12, and 12. And we know that we can divide it by how many pieces of data there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, if we add up all the terms on the top plus n, we get the number 80, which makes it a little bit easier to work with, not so messy. And if we do my cross-multiplying idea, which I can do, I end up with 80 plus n on one side, because 1 times, that stuff is still the same. And the other side, we end up with 91. Well, I can solve for n pretty simply. I got n is 11, which makes sense in terms of where it lies in the data. N was probably either a 10 or an 11. We didn't know. Couldn't be a 12 because that would make it a mode. But the math actually wasn't too difficult. And so that's how we can play with mean, median, mode a little bit. Now, one of the questions we need to ask ourselves is, which of these should we use when we talk about the word average? Because we use that word in our language every day, and we use them kind of interchangeably, and we probably shouldn't. So, when we discuss average, the first thing you need to do to decide mean, median, mode is examine the type of data that you have. Okay? That's important. Look at the data. Because if you have data that is fairly clustered with no outliers, then the mean is usually your best choice. And we did a quiz in our class, and everybody got, it was out of 10, and everybody got between 5 and 10. That's pretty clustered. I could use the arithmetic average as my average, my mean. But if you have things that have outliers, well then outliers are thrown off when you do the calculation. It throws off your mean. For instance, if I have the numbers 1, 2, 3, and 40, well, the median would be the halfway point of these two things, 2.5. That describes it pretty reasonably. Most people score around 2.5. but my arithmetic average, if I was to add that up, I would get 46 over 4, which is, what's that, 12 point, no, not 12, 11.5. Well, does 11.5 describe my data very well? Not really. Nothing's very close to it. The 3 values are way below it, and the 40 is way above it. So those numbers, the mean is thrown off by the fact that we have that one outlier, the number 40. And when do we use mode? Mode's used for popularity. So mathematically, we wouldn't use that very often. Unless we're looking at things like, which is the most popular size? Well, maybe we have hat sizes, and then everybody's got 9-inch heads. Okay, well, we measure them, and that's important. Okay, but median and median and mean are what we will use most often. So let's try the next thing. I want to find an appropriate average for the following sets. But the good news is I don't want to do this by hand anymore. We can do it by hand. There's nothing wrong with doing it by hand. We just want to be able to use our technology to save us some time on repetitive calculations. So let's get those graphing calculators out and put our data in, as we always have. So we're going to start off by going to Stat, turning it on, of course, Stat, Edit, and put our stuff in list 1. 6.5, 7.5, 7, 8, 7, 7, 6, 7, 7. Okay, all my data is in. How do I actually calculate things now? Well, we're going to go back to our Stat menu. And at the top up here, notice it has the word Calc. So we're going to arrow over to Calc. And we want to do one var stats, because the only variable we have is hat sizes. That's a single variable. Okay, our list is where we put our data. We put it in L1, so we're good. Our frequency list we don't have to worry about right now. We'll talk about that down the road. So we're just going to write down to calculate. Okay. Now, the mouse jumped there, but when you do that, you got to press enter for calculate and also again for one var stats to get the list. So at the top, we have our mean. Now, your graphing calculator always goes X bar, that's what it says. So it's kind of up to you to decide X bar or mu. Most of the data we deal with is going to be samples, so X bar is a safe thing to go with. Okay, so I've got X bar is 7.21. We also have in this list our median, but to get it, you have to go down. Because if you notice on the screen at the very bottom here, it has this down arrow next to the end. There's more information down below. If we use our down arrow, we can get down to the next list of data, and here's our median right here. Median is 7. The graphing calculator will not give you mode. Okay, there is no mode on the graphing calculator. It's not designed to give you the mode. You have to figure out modes by yourself. So in this question, if I look at my data, I've got my mean, my median, my mode. I can figure out I've got a whole bunch of 7s here. It's pretty obvious that the mode is 7. Which of these numbers best states the average for what we're looking at? Well, hat sizes, I want to look for the common size, what most people buy. In that case, mode makes the most sense. So it's one of the rare cases where we actually do use mode. Most situations we won't, but we're thinking there that I want to look for something that's common. Let's try the next one. Okay, I want marks on a test. Well, right off the bat, I know this isn't about a popularity thing, which is the most common mark on a test. I kind of want to know how the class did on average. So we're going to go back to our graphing calculators. We're going to do the next set. So I'm going to go back to Stat. I'm going to go to Edit. And instead of clearing the whole memory this time, I'm just going to go up to the top where it says L1 and press Clear. Press Enter to complete it, and it gets rid of your data for you, instead of having to clear the whole calculator every time. We'll put our new data in. Okay, as I'm typing, I'm looking at my data and thinking to myself, are these close together? Are they far apart? And I noticed right off the bat there was a 4 in there. And all the rest were sort of like teens and up to 20. So it signifies to me that I'm thinking there's probably an outlier. We'll do our calculations, Stat, Calc, one var stats, down to the bottom, and there we go. My mean is 14.5. My median, if I go down the list here, is 15, which is fairly close together. And mode I'm not going to worry about, because I know it's not a popularity thing for quizzes. Which of these is most appropriate? Well, the fact is they're really close together, so it's not a huge difference. You probably could use either one, but I think it makes more sense to use median this time because of this outlier, or what we think is an outlier. We know we have a test for them, but for this, we could just think of that as being an outlier. I got one more set for you. Give this one a try. Okay, the hours spent doing homework. Back to our calculators. Let's clear out that data. So stat, edit, go up to the top and clear. Put our new data in, 2, 1.5, and so on. Be careful with the decimals, make sure you have them in there. As we're looking at the data, I'm thinking already in my head, these are, oh, they're all pretty close together. There's very little differences between them, variation. So this time my mean, my average is 1.92. My median, I'm going to guess it's not going to be a whole lot different. No, it's not. It's 1.95. But which would I use for my descriptor? I would probably use mean because there are no outliers this time. Every one of those data looks pretty close together. The smallest is 1.5. The biggest is 2.2. That's not very big, relatively. Okay, so we learned how to use some technology there. We learned about which one to use, mean, median, mode. Our last idea for today. Okay, sometimes data is weighted in different ways. Okay, some things are considered more important than others. For example, when we do this course, our tests are worth more than assignments. Okay, they're weighted more. They're a higher percentage. Okay, when we're looking at math that deals with weighted means, something that reflects the relative importance, we have to do a slightly different calculation. So here's our new calculation. We call this XW, X bar W, okay, weighted mean. The top part, okay, is the sum of each value and its weight multiplied together. The bottom is the sum of the weights. Now that might sound confusing. We'll look at some examples of how this works. Okay, so we have Jumbo Video. They're interviewing job applicants for a new vacancy in the sales staff. There are 3 parts to the process, each of which is given a different level of importance. We have 3 people applying for the job, and they got these scores. 1 is low, 5 is high. Who should they hire? So let's look at Ray. Ray's average on these scores, his weighted average, is made up of his resume, which he scored a 3 on, and resumes are weighted pretty good. So I'm going to do his score times the weight. He also scored a 4 on his references, but they're not weighted very much. They're only weighted as a 2. And then his interview, he scored a 3, and it's weighted the most. It's weighted as a 5. So this is my value, and this is my weight. Value and weight, value and weight. I want to divide that by the sum of the weights. I used a 4, a 2, and a 5. And so for Ray's score on top, 12, 20, 35, divided by 11, Ray scored a score of 3.36. That's his weighted average. So not just add up the 3, 4, and 3 and divide by 3 things. I need to involve the weights in there. We're going to do the same thing for Corey. Okay, what's Corey's weighted average? So Corey scored a 2 on the resume. He scored a 4 on the references. And he did really good in the interview. He scored a 5. Okay, we divided by his 4 plus 2 plus 5. And he scored 41 points relatively. He scored 3.73. And then we have Jeff. Jeff has the same parts. And he scored scores of 4 on the first thing. And 4 on the, he did really good on his references. But he had a really poor interview. He only scored a 3. And it's worth a lot. It's worth 5. So if we do his, we get, what's that, 24, 39 over 11, which comes out to 3.45. So who should get the job? Who has the best weighted average? Well, obviously this is the highest. And it's not because he had the highest three numbers, because he actually scored lowest in the resume. He was equal to everybody in the references, but because this was weighted the most, it was weighted as a 5, the fact that he got a 5 in the interview got him that job. It was more meaningful and had a higher weight to it. And last one, I'm going to get you guys to try this one if you can. Oh, skipped a page there. Oh, I lost a page there. How about that? All right. Well, I guess we're going to stop there then because I seem to have lost the page. Okay, give these questions a try. If you're stuck, come see me and we'll figure out what happened to that missing page there. It's just more practice of the same thing. Okay. Homework, obviously, on the page. Give it a try. If you're stuck with things, come see me.